All right. So I want to make a comment. I kind of put a star here about the composition part right there, but the real way that we kind of care about composition is actually with this example 6 here. So I kind of want to emphasize this example 6. It's going to be really important for us in this course. Okay. So it says express h of x equal to cotangent squared x as a composition of two functions. So in other words, h of x is supposed to equal to f composed with g of x. And our question is, what is f? What's the outside function? What's the inside function? So the first thing I want to point out to you is that when we write this notation really means cotangent of x quantity squared. So trig has this weird notation that they use sometimes where they put the square next to the trig name instead of around the whole thing. And I suspect the reason why is when you write something like cotangent of x squared, does that mean cotangent of x squared, or does that mean cotangent of x squared? Like, I think that notation is not clear. So then instead, they put the square right above the cotangent, so you know you're squaring that. I don't know, that seems lame to me, but that's how we do it. So when we look at this guy, what's the outside function going to be? And what's the inside function going to be? The outside function to me looks like squaring. The inside function to me looks like cotangent of x. Does that make sense to everybody or not? Okay. Okay, so so if we wrote this guy, if I ask you what is the outside function and what's the inside function, what do you guys say the outside function is for B? You can type in the chat box.
Can you explain A again, please?
Sure.
Section A, please.
Okay, good. I'm so glad you stopped me because I wasn't sure if it was obvious or not. So that means it's not. So let's go back. And if you don't mind, I'm going to draw a picture. Or maybe I drew a picture already. I did draw it already. I'll cut and paste this picture. Or copy and paste, I should say. So, so when we're dealing with this composition of two functions, we need to see one function living inside of another function. So I'm calling G the inside function, and I'm calling F the outside function. And the reason why I call G the inside function is because we plug G into the independent variable of F. Okay. So when I look at H of X like this, I need to see something on the inside and something on the outside. And for me, visually, I can kind of see that, oh, I see squaring and I see cotangent, but the squaring literally looks like it's sort of outside and the inside looks like it's going to be cotangent. So I can do this form of guess and check where I say, okay, I'm going to call the inside cotangent of X. I'm going to call the outside X squared, and then I could just plug it in to see what happens. So anywhere I saw X, I'm going to plug in a cotangent. So this is cotangent X quantity squared. Let's say I reverse it. let's say I thought, maybe the inside is x squared and the outside is cotangent x. Then when I plug the the x squared into cotangent x, I'm going to get cotangent of x squared like that. So these guys aren't really the same thing. And the one that I really want is this one right here. So that's why I'm going to say, okay, my inside, which is g of x, that's going to be the cotangent x. And then the outside, which is the f of x, that's going to be the x squared. And then when you plug the cotangent in for x, you're going to get cotangent of x squared. Uh, does that help somewhat?
A little bit.
A little bit. I
Yeah.
think B is easier than A. So let's take a look at B. Maybe the next version of this, I'll switch the order around. So when I look at this guy, I see two functions, right? I see 2x and I see sine. So I'm thinking sine of x, I'm thinking 2x, and which one is the inside function and which one's the outside function? Well, when I look at this, to me, the 2x looks like the inside, um, because when I take the 2x and I plug it in, when I plug this guy in here, then I'm going to get the j function. So that means that this guy is outside. Does that make sense? So then our f of x is going to be sine of x, and our g of x is going to be 2x. And when I do f of g of x like this, that's going to be sine of, and anywhere I saw x, I'm going to plug in or it's going to be f of 2x like this. And then f was sine of something, and then you got to plug the 2x in there. So maybe I'll write it like this. We have g of x like this. The g is going to be a 2x. So then this is going to be 2x like this. And that's exactly the j function. Okay. Let's take a look at, I'm sorry, let's go down to this classwork here. These are more complicated questions. Try C. Why don't you guys all try C right now? Write it as a composition of two functions. Give you a couple seconds to try that. Oh, Benny, I was just about to say, let's do that thing where we type our answer in the chat box and hit enter when you've already typed it. So never mind. So everyone look in the chat box and see what Benny wrote there, because I think that his decomposition there is a good one. So he is saying that the outside function f of x is going to be 1 over x. And then he's saying that the inside function is going to be x squared plus 1. And I think that looks correct. Okay. Does anyone have a different answer? Because there is more than one right answer. Let's try a different one. Someone, someone type a different answer in the chat box. Anyone? This is very interesting. Guys, everyone, look what Cigar wrote in the chat box. Ah, okay. I have comments to make on each of these three answers over here. So Hao-Wei wrote x to the negative 1. Hao-Wei, your answer is the same as the one that Cigar, or no, not Cigar, the one that Benny wrote, because x to the negative 1 is the same thing as 1 over x. So Hao-Wei, your answer is no different.
Okay.
Cigar, do you see how your f function is 1? So if you did f is 1 and g of x was 1 over x squared plus 1, then when you do f of g of x, that's going to be f of 1 over x squared plus 1. You know what the output of that is? That's just 1. So we don't get our original function of k back. Okay. Yeah. But I mean, definitely glad that you're thinking and stuff. There was a couple of other answers. Catherine, I like your answer. Ryan, I wanted to make a comment about your answer. F of x equal to x is not an interesting function. Like if you allow that to be a function, then everything can be a composition of two functions, right? So, if I have something like k of x equal to x squared, I mean, we don't really think of that as a composition of two functions. It's just kind of one function. So this is called the identity function, and it's not really a useful composition. So that was not really what I had in mind. But again, I like it when people are thinking. Don't be shy of putting your answers in the chat box. I think Ji-Jun and Catherine have good answers. So both of them said the same thing, which is the outside function is 1 over x squared, 1 over x plus 1. And then in order to achieve the function, we can replace that x with an x squared. This also works. Okay. So I think both of those work. So one of these is better than the other for the purposes of calculus, and this one is better for calc. All right. So for example 3, we're going to have a composition of 3 functions here. So what we want to do for example 7 is we want the outside, we want the middle, and then we want the inside. So take a second to think about those guys. Or actually, I have ones for you to try, so maybe I should just do this one instead of asking you to try it. when I look at this j of x, what's the outermost thing look like? Well, I see that giant square root. So to me, the outside looks to be the giant square root thing. So square root of x. And then when I look on the inside now, I'm looking at sine of x plus 1. It looks like sine is on the outside and x plus 1 is inside of the sine. So the inside guy is going to be x plus 1, and then the middle guy is going to be sine of x. Does that make sense to you guys? Is there any questions?